Hello and welcome to Chapter 1, Introduction to Computers and Programming. Chapter 1 covers the following sections: Why program? Computer systems, hardware and software. Programs and programming languages. What's a program made of? Input, processing, and output. The programming process. And procedural and object-oriented programming. Section 1.1. Why program? Without programming, computers wouldn't do very much. Programming allows us to use computers to perform a variety of functions. Everything from retinal implants that restore vision to the blind, to modeling the composition of the Earth, or mapping the human genome. The percentage of new STEM jobs by area through 2018 is expected to be 71% for computing. Section 1.2. Computer systems, hardware and software. Hardware is the physical pieces of the computer. The 5 main hardware components are the CPU, or central processing unit, RAM, secondary storage devices, input devices, and output devices. The CPU, also known as the processor, is the brains of the computer. It's responsible for fetching instructions, decoding them, and executing them. The parts of the CPU that are responsible for fetching and decoding the instructions is known as the control unit. The part of the CPU that's responsible for executing the instructions is known as the ALU, or arithmetic logic unit. RAM is short for random access memory. It also is known as main memory or primary memory. RAM is a form of volatile storage. This means that it temporarily stores portions of programs and data that are currently in use. RAM is volatile because when power is lost, the contents of RAM are lost as well. Secondary storage devices are a form of permanent or non-volatile storage. These include hard drives, whether they're mechanical or solid-state hard drives, flash storage, like a USB drive, external hard drives, SD cards, CDs, and even floppy disks. The purpose of this type of memory is to store information for longer periods of time. Input devices collect data from the outside world. Examples are keyboards, a mouse, even a joystick or a touchscreen. You may have used a stylus or a trackpad. These are input devices as well. Also, webcams, microphones, DJ mixers, samplers, and scanners are all examples of input devices. Last, output devices send data to the outside world. These include monitors, headsets, speakers, vibrating controllers, and printers. If you think, you can probably come up with some more input and output devices on your own. Section 1.3. Programs and Programming Languages. A program is a set of instructions that the computer follows to perform a task. Programs are also known as software. In algorithm, is a recipe for solving a problem. Programs are composed of one or more algorithms. Algorithms, more formally, are a set of well-defined steps that terminates. The instructions written in a programming language are written in source code. We'll be writing C++ source code. When we write C++ source code, the file will end in an extension .cpp. A CPU carries out these instructions, but a CPU does not understand the source code that we'll write. Instead, that source code has to be converted or translated into a language that a CPU can understand. That language is known as machine language. It's the binary language consisting of only zeros and ones, but no twos or threes. Once the code is converted to binary language, the result is an executable file consisting of ones and zeros. The process of translating from source code to machine language is known as compiling. In reality, the process is a little more complicated and bears some further explanation. The compiler converts source code into object code in an object file. Object files have the extension .o. Our source code files, which end in the file extension .cpp, might contain references to code that aren't in our source code files themselves. This is very common, and in these cases, the preprocessor modifies our source code before sending it to the compiler to be converted to object code. Finally, another program called the linker combines the object files with certain routines to hook them up to the computer hardware, like input and output devices. Once the linker is finished with this step, an executable file is created. The executable file contains machine language instructions, or executable code, and is ready to run on the computer. The file extension for an executable file in Windows is .exe.